All right, my name is Joseph Lombardi. My team members are James Boyette and Miles Biggs. Next week we're doing the Rankin cycle experiment. So first off, lab safety. Obviously, you gotta wear the proper PPE, safety glasses, closed-toed shoes, and long pants. Careful and be aware around hot surfaces because there is going to be a lot of hot surfaces with this experiment. Accurately and carefully pay attention to startup and shutdown procedures and follow all the instructions. Alright, so the Rankin cycle has four main stages. It has the pump, boiler, turbine, and condenser. The working fluid typically for Rankin cycle is water, but it can be other fluids. Water typically undergoes, it's got to basically be any fluid that can undergo phase change during the cycle. And Rankin cycle, the whole system is kind of using coal-fired and nuclear plants. So, on the left we have an ideal PV diagram for a Rankin cycle. On the right we have a TS diagram. So obviously for the PV diagram, 1 through 2, that's the pump. It's constant pressure. 2 through 4, they kind of combined the boiler and the turbine section. Adiabatic, and then the condenser is again constant pressure. When we look at the TS diagram, 1 through 2, that's again the pump, which is rising temperature, and it's a straight line because it's constant entropy because this is ideal, and then this is the rest. So an ideal cycle, obviously it's theoretical, it can be achieved. It's more of like a goal that you want to have whenever you're designing these kind of things. It's reversible and it has higher efficiency than any real cycle. So for real cycles, they are irreversible. There are pressure drops that occur due to fluid friction in the boiler, condenser, and piping, and there are heat losses from the steam to the surroundings. So the goal of the experiment is to calculate the mass flow rate of the system, pump work input, boiler heat input, condenser heat removed, turbine work output, turbine efficiency, and cycle efficiency, and to kind of observe the differences between the ideal and the Rankin cycle. So this is the apparatus. It consists of the boiler, the turbine, condenser tower, generator, data computer, and then liquid propane, and a bunch of other little things. So these are the equations that we're going to use to calculate the previous things mentioned. The pump energy balance, boiler energy balance, turbine energy balance, condenser energy balance, ideal energy balance, cycle thermal efficiency. So these are the sample calculations for all of those. The work from the pump should be about 1.34 kilojoules per kilogram. Heat of the boiler, 2,743. Work of the turbine, 571. The heat condenser, 2,173. And the cycle thermal efficiency should be about 20.71%. So yeah, any questions?